Welcome everyone. So this is another very famous problem. Uh, so given a linked list, we are trying to find if there is a cycle in it, and by cycle it means that one of the nodes sort of like points back to a node that came before. And so if you keep following the next pointers, you would essentially never you go out of the loop, right? So yeah, in this video I'm going to go a bit faster. I want to see if I can record video in under 10 minutes. So yeah, so there are two ways to solve this, right? So one is you sort of like uh, do a brute force approach where you store your nodes in a set, and then every time you see a node, you check if your set has it, right? If the node is already part of the set, you know that you have a cycle, otherwise you don't, right? So sort of like this. So you will have a set over list node, and then yeah, of course, like the boundary conditions. So if you have a if the head is null, you don't have a cycle, you can just exit straight away. Now now you can just iterate over the node. So you can say, well, let current is equal to head, and then I'm gonna change the head in the end to be current's next. Let me change this to be optional, and then if you have a set, in the set, if this already contains current node, that means this is a cycle. We have come back to a node that we saw previously, right? Otherwise we'll just do an insert for the current node and move on. In the end we should return false because there is no cycle. Yeah, so of course, like, I need to implement the hashable protocol. So I always forget this. So static in an interview, you probably don't need to implement this because this is like boilerplate and there's nothing really significant here. So so we want to compare if the two object instances are same. So I can use object identifier here, if I can spell it right. Identifier of LHS, if it's equal to identifier of the RHS. We need to implement one more method, which is the hasher. What is this called? I think it's called hash into I always forget this. I think it's fine. You can look up the documentation for this one, but I think this should work. So yeah, so this works, and yeah, this is O of n time and O of n space as well, because you in the worst case you would essentially have the entire list stored up in this set by the end of it, right? So the optimal solution in this case, which doesn't use any space, is kind of interesting. So if you imagine, like, there are like two runners on a circular ground, and let's say one of the runners is faster, right? So so if you think, like, let's say you have a race, and the track is circular, right? So both of the racers, let's say they start at node 2, and one of the racer is kind of faster, like twice the speed of the slower racer, right? So in that case, as they're running in the loop, the faster racer will overtake the slower racer, right? They would essentially catch up with the slower racer when they overtake them. So that's the concept that we are going to use here. So essentially, you take 2 pointers. So you say slow, it starts at head, and you take another pointer which is, let's say, called fast. It also starts at head, and so if as you are doing this, if you ever come across nil, that essentially means that there is no cycle, right? Because you ran out of the node, ran out of the list, which means that the next pointer of whatever node you are pointing to doesn't have anything ahead of it, right? So in that case, there is no cycle, so you can stop. So if slow is equal to nil, or slow dot next, if that is nil, no, I should say if slow is not equal to nil and slow dot next is also not equal to nil, only then I want to go inside the loop. Otherwise, I should stop. Now, why the dot next? That you'll understand here. So if I do slow dot next, so this runner is going by this runner is taking only one step at a time, right? And the fast runner is going to take 2 steps at a time, right? So now I made this check above here which says slow is not equal to nil and slow dot next is not equal to nil. The reason being is that if either of these two are nil, this would be nil as well, right? So I don't have to check for fast here. I can just check if slow is nil or slow's next is nil as well. And now if slow, if that happens to be equal to fast, I know that there is a cycle and I should return true. Otherwise, I can just, whenever I come out of this loop, I can return false. And I'm using triple equal to here because I want to compare two objects, right? Like the instances are similar or not the values. So yeah, I believe this should work unless I have, yeah. So this works as well, and we just basically avoided using the set. So this brings down the space complexity of to O of 1, and this concept of fast and slow runners is actually very handy. You'll use this in some other problems as well that I'll try to do videos on later as well. Thank you.